Ever wonder how the apps on your phone actually save and retrieve your information? Under the hood, almost every action you take sends a tiny packet of data straight to a centralized server. When that server processes your data, it generally performs 4 basic tasks: creating new information, reading existing data, updating details, or deleting records. And in a standard setup, all of these actions are routed into one single database. For the vast majority of websites and applications out there, this all-in-one approach is perfect. It's straightforward to build, and it gets the job done. As long as your app is dealing with a normal, predictable amount of traffic, a single database can easily juggle both reading and writing tasks without breaking a sweat. But let's imagine a scenario where that predictable traffic suddenly disappears. Picture a massive Black Friday sale on a popular site, and everyone is trying to snag the exact same pair of headphones. Millions of users are hitting the page at the exact same moment just to check the price. In database terms, that's a massive flood of read requests hitting your system all at once. Right in the middle of this frenzy, the seller decides to put the headphones on sale. They drop the price, sending a critical update command into that exact same database. Here is where the system hits a wall. To safely rewrite that price without showing people corrupted data, the database has to lock itself down. It has to freeze all those millions of readers while it processes that one single update. By forcing your system to handle complex data updates and massive waves of readers in the exact same place, the database becomes overwhelmed. Eventually, a high-traffic app built this way will choke, slow to a crawl, or completely crash. The solution to this traffic jam is surprisingly straightforward. You physically separate the jobs. In software design, this is called CQRS, or as it's known, Command Query Responsibility Segregation. This chart shows exactly how it works. Instead of one overworked database, you split the workload. On one side, you build a command database. This path is strictly dedicated to creating, updating, or deleting records, basically anything that involves modifying the data. Because this side of the system never has to answer millions of people asking for the price, it can focus entirely on executing complex data changes safely and securely. Then, on the other side, you create a query database. This is a completely separate lane optimized exclusively for reading. The data is stored in a flat, ready-to-go format, so it can absorb millions of requests without ever locking up. If the read and write databases are entirely separate boxes, how does the reading side actually know when the price is changed? You connect them using an event stream, which acts like a high-speed messenger between the two sides. Now, every time the command database successfully processes an update, it fires off an event. That event shoots down the pipeline and tells the query database to update its flat file to the new price, say from $50 to $40. Because it takes a fraction of a second for that message to travel, the two databases aren't perfectly synchronized every single microsecond. In system design, we call this eventual consistency. Developers happily accept this trade-off. Tolerating a split-second delay where a user might briefly see an outdated price is a much better alternative than watching the entire application crash right in the middle of your biggest sale. To keep this entire split system invisible to the user, developers add an API gateway to act as a front door for the application. Think of the gateway like a highly efficient traffic cop. When a user clicks on a product to check the price, the gateway sees they just want to read information and waves them down the high-speed query path. But if a user places an order or updates a profile, the gateway detects the change and diverts them down the separate command path. This overarching design ensures the complex, careful work of changing backend records is entirely isolated from the high-volume work of serving information to users. Now, as powerful as CQRS is, it's not a perfect fit for every single project. Building it means managing multiple databases, event pipelines, and extra server infrastructure. If you're building a blog, a simple startup app, or an internal team tool, the traditional single database approach is still the smartest and most efficient way to go. But CQRS really shines in complex systems where the sheer volume of users asking to read data vastly outnumbers the amount of data being written. When you reach that level of scale, CQRS offers a robust division of labor. It gives large-scale applications the exact architecture they need to handle immense traffic without collapsing under their own weight.